Hello everybody and welcome to this webinar by Uleska, which is covering FormJacking, which is going to tell us all about what FormJacking is, how it can be attacked, how it is becoming very prevalent, especially in 2018 and now in 2019, and what you can do about it. My name is Guy Robinson. I'm the founder of Uleska. And I'll be giving this presentation and webinar on FormJacking based on some research that we have done ourselves and with a couple of other large companies to look into the issue that is FormJacking and what the industry as a whole can do about it. So just a quick mention about myself and about Uleska. I have been in software and cybersecurity for over 20 years. I have been a senior security architect at organizations like Citigroup. I've been a penetration tester. I've been a security consultant. I'm also a global board member for the organization of OWASP, or the Open Web Application Security Project, which is a worldwide organization which advises and builds tools and projects that helps with the world of software security. A bit about Uleska. Uleska, we build applications and platforms that help organizations test dynamically in a DevSecOps way for application securities issues, just like FormJacking. We automate in the best and brightest of the application security tools so they can be run automatically day in, day out without needing manual security skills. We also translate those technical issues into what we call monetary business risk. So instead of a large organization having tens of thousands of SQL injections potentially, we translate those into the monetary business risk of those technical issues so that you can help prioritize and know what the business risk is to those various technical issues. And we also then provide these neural dashboards and reports that allows CISOs and CTOs to communicate the security of these application security issues across many teams, across many applications and business units, etc. It's one of the issues that the application security industry has at scale, in that we can't just keep on pushing around technical security issues and the numbers of those. We have to really understand the business risk in a quick and efficient manner and be able to communicate that so we can understand that our security strategies are working and our risk profile from application security is getting better or worse. So what is FormJacking? In this section, we're going to cover just a quick introduction to what is the technical issue termed FormJacking. So FormJacking is essentially a new take on an old type of vulnerability. It is a JavaScript type attack where attackers are able to introduce their code into a website running on a browser and use that to extract information that they would want from a user session. So it's become more popular in the last few years for different reasons that we'll cover later on, but its popularity is growing dramatically. It's been made famous this year mostly by the Semantic Internet Threat Report from 2019, which listed it as one of the biggest issues from 2019 and from 2018. It's estimated to attack around about an average 4,800 websites per month. That's around about 240 websites per day. And that's very interesting that it is attacking the websites. That is the website itself that's being attacked. Therefore, any users subsequently using that website, all of them are potentially subject to the attack as well. So that allows it to grow very, very quickly. So one of the main things to keep in mind is that this type of issue, whilst it's actually quite simple to exploit, is quite difficult to test for, because it essentially attacks a third-party source repository or a third-party entity to your main business site. So if you are a bank or if you're a large organization that has an extensive website, this system or this type of attack is not essentially attacking your infrastructure. It is not introducing code inside your code bases or inside your applications as they are served. It is introducing negative code whenever the user's browser is actually rendering that website, which means it can be very hard for a large enterprise organization to understand themselves and detect themselves if that issue is being exploited. It also has a temporal aspect because it could be that a system or an application that is using this JavaScript is absolutely fine one day, but then if that third-party code changes the next day, then that could be when it's exploited. So the code can change quite quickly, but one of the issues is that if testing is only done, say, every 6 months or every year, it can be a large window where that type of exploit can be happening before a system is actually fixed. Of course, what tends to happen is the clients of a website start reporting the bad actions, and that's how this gets found very quickly, or found by websites and by the enterprises running them. So how does an attacker exploit FormJacking? So we're going to keep it quite simple here, but essentially a classic example of FormJacking is where a JavaScript script tag is used to introduce the JavaScript file to use. So for example here, this has a potential path to a JavaScript, but that could, in the form of FormJacking, that would actually be an external URL. So for example, http://badguy.com/javascriptfile.js. So in this case, it could be that the website is wishing to use some functionality that is provided by the JavaScript. It could be something as good as Google Analytics. It could be tracking mouse flows around the website. It could be providing different types of functionality that is commonly used. And instead of the organization or the software engineering team within an organization creating this JavaScript themselves, they bring it in from third parties. So some very popular examples are things like Node.js, things, big JavaScript frameworks like that, where essentially all of that is brought in from a third party and served from something like Bitbucket or GitHub or from something popular like that. So whenever those third-party JavaScript files are brought into the application, they essentially have access to anything running on that particular website in the browser at that time. So there's lots of different ways. It could be in the HTML we've seen here. There's also different ways, if you look it up, within JavaScript to bring in third-party JavaScript files from other resources. But once they are in and once they are running within a web page running on a web browser, they can essentially read anything in the document object model or the DOM. For example, they can read any of the assets on the web page. So any text or any values that are written there, they can read. Anything that is entered into the website, for example, username and passwords, passport numbers, addresses, names, etc., they will be able to have access to and read. And they can also even read things like mouse flows, any URLs that were given to that website, etc. They have access to a lot of information, and that is how they're using this to extract information such as credit card numbers, such as passport numbers, etc., because they have access to that and they can send that straight back to a repository which is owned by the attacker. Not only can they extract it, it also has to be mentioned that they can modify the data as well. So if, for example, you're typing some information in like a credit card number or an address or an element to have an account number that say money should be sent to, they are able to modify that data before it is sent to the server. So that's another type of attack that could be costly in this particular FormJacking scenarios. So it is interesting that the FormJacking attacks, they actually target the code that's part of the website, and they don't attack the business itself. So they attack it then when it runs on the customer's computer that's displaying the website. Like many websites these days run JavaScript. It's actually there are ways to turn off JavaScript on your web browser, and if you've ever tried to do it, a lot of websites simply fail to work. They just can't operate these days. JavaScript is very common in today's websites, and it's depending on the resources that you're using for software security. The loading of these third-party libraries is actually called different things. So they can be includes, they can be called simple JavaScript includes, or tools like Burp will call them cross-domain script includes, and organizations like GoWasp call them tags for different types of functionality such as analytics. So the way the attack happens is that the web server inside an organization, this could be a large airline, this could be a bank, etc. The web server serves back the web page to the customer end user, and that is HTML and probably JavaScript that is served by the banking application themselves. As that end user's browser, be it Chrome or whatever, is rendering that web page, it will look for any JavaScript includes that need to be rendered, and if it finds one, it will actually go off to a third-party repository, something like GitHub or Bitbucket, whatever. And although we're using the Bitbucket image here, that does not mean at all that Bitbucket is specific to this type of attack. It's just we're just indicating any sort of third-party repository that could host the JavaScript. And as that browser in step 2 here is rendering those third-party includes, it's able to get that information outside of any interaction from the business, from the airline or from the bank. I was served it through step number 1. Now, as the bank or airline, etc., has developed this website, and they have obviously done their own system testing, their own unit testing, and have brought in that JavaScript library for a specific function, and it operated properly at that time. At some time later, if this third-party repository is either maliciously breached, if it's deliberately taken over, for example, maybe it's a third-party open source library that has just fallen out of support and somebody else has taken it over, or if there's other ways to get attacks into that third party, then that is how this malicious JavaScript, as FormJacking, comes into the web page that is being rendered on the end user's browser and has access to all that bad information. All that information, because that is where the credit card numbers are either being shown in a web page or typed in. That is where the passport numbers or other personal information again are being typed in or displayed in response to a customer query, for example, for a bank's own accounts. And things like SSL or TLS don't matter here at all. Things like authentication, etc., doesn't really matter, because this FormJacking JavaScript has been loaded into that page outside of the authentication, outside of the SSL, and has access to all the information inside it. So wrapping this around SSL and TLS and having this authenticated does not at all protect against FormJacking, which is one of the main reasons why it's so popular as an attack. So the nature of FormJacking attacks: they attack the customers, not the actual websites themselves. So that meaning that just one website effectively, attacking just one website effectively attacks all the customers of that website. You're not getting access to the back-end infrastructure of the bank or the airline. You're not able to see anything in the back end. You're not able to get inside the firewall. You don't need to. You actually get access to the interesting data that's sitting there on the user's browser as it's being displayed or typed in. So FormJacking attacks, that's why they're incredibly effective at stealing information from customers who are using the organizations. So the classic examples have been British Airways in October 2018, where a single website breach affected over 500,000 customers. And another one is Ticketmaster, where a similar type of breach affected over 40,000 customers, and they're both examples of FormJacking. So we see here that one attack has been able to, attack of one website, for example, the British Airways website, that one breach or injection into the website has been able to attack then 500,000 customers of that website, because they are the ones that are using it. So according to Semantic, which in their Internet Threat Report last year had a couple of very interesting quotes, I advise you to download that their document and have a read of it, because it has lots of good information on FormJacking. They actually say that the telemetry shows that often small and medium-sized resellers selling goods ranges from clothing to gardening equipment to medical supplies have had FormJacking code injected into their websites. So it is a global problem with the potential to affect any business that accepts payments or from customers online. Now, we would extend that at Uleska to also include any website that accepts or displays sensitive information from customers, or websites that are trusted by customers. So as you can see, the potential for FormJacking to affect numerous important sites on a global scale has to be taken very, very seriously. And it's this scaling problem which actually allows it to be so popular these days. You attack one website, or you attack one project, open source project which gets onto one website, and then you're able to attack, say, 3 million users if each of those 3 websites have 1 million users each. And this is one of the very interesting natures of FormJacking, is that you are essentially attacking the smaller open source third-party types of projects. You're not having to attack the large defended bank, the airline which has spent 300 million on security in the last few years. You're able to attack a small revenue organization which is being trusted implicitly and maybe unknowingly by a number of these large organizations. And by doing that, by attacking one, say, very, very popular open source project, which is then used in, say, 100 different large company websites, you're able to attack all the customers of all those 100 different websites without having to go through the pain of attacking any of those actual business organizations. Instead, you're attacking one of the smaller organizations which has less security defense. And that is why we have such large numbers of FormJacking attacks happening in 2018 and in 2019. You don't have to enter the business infrastructure. You don't have to pass any IDSs. There's no firewalls that will stop you. There's no code reviews that would potentially find this type of thing. This is all the ability for you to get into an open source project and have anybody who trusts that open source project be vulnerable to your particular attack. So the question is, what can we do about it? So the technical flaws behind FormJacking have been known about for a number of years. In fact, this is what used to be used for a lot of crypto mining problems that happened in the past. So it used to be that this type of attack was used by crypto mining, which meant they stole CPU resources from your own PC to help them mine coins, and they made money from that. That's how the attackers used it. Now, because the price of the cryptocurrencies all tended to drop, and that became less of a business opportunity, they have now turned to stealing the data, because the obviously return on investment for stealing data from these types of systems is a lot better than the return on investment of mining cryptocurrencies. So the flaws behind FormJacking have been known about for a number of years. Recent breaches have only slightly changed of how this is manifested. Now, the OWASP has advised these types of controls for some time. So from their OWASP top 10, item A9 has stated for a long time that using components with known vulnerabilities is an issue. Now, that's many times translated to actually be using third-party components that have these types of issues, because it could well be in this case that whenever the organization or the software team that were building the website, whenever they were testing the JavaScript library, that it worked fine, that there was no issues, that there was no flaws. But as we've shown, since it's a third-party project, since it's loaded dynamically by users' browsers, the software team has no control on when those updates are applied, when those changes are applied to your website. There are a couple of libraries added to the HTTP specs that would allow them to control an element of that, but unfortunately, from a business point of view, those headers would stop the website rendering rather than stop the JavaScript functioning, rather than providing a better way to mitigate these problems. OWASP also has a thing called the ASVS, which is the Advanced Security Verification Standard. Now, it's recently updated to version 4, but version 3 had this advisory that to verify all components, such as libraries, modules, and external systems that are not part of the application, but in which the application relies to operate. So again, that explicitly applies to what we're saying here. This is a library which has been included into the website for whatever business logic reason, whenever is needed there, but because that is relied upon, it's actually part of the website. Any flaw in that which is outside of the business control allows your customers to unfortunately be affected. So there are some suggested solutions that could help mitigate your chances of being attacked by FormJacking. The first one is to carefully select the third-party code that you're going to use on all website and pages. Now, this means that you have to unfortunately have a list of third-party JavaScript libraries and the like that you wish to use and that you trust. And you would need to audit those third-party libraries to check if there's any potential security flaws in those. Now, after that, you can take your third parties and consider them in two ways. The first one is, can the third parties assure their code? So you have organizations maybe like Google. The obvious one is Google Analytics, and there's many other reputable businesses out there that have JavaScript which does get loaded into your code, into website dynamically from the user browser. So if you can make a decision to trust that third-party supplier, if, for example, you've checked out Google or you've checked out these other organizations and they have security policies or they have ways of assuring you that the code, the JavaScript they serve that would form part of your website has security checks, and that other organizations or other developers don't have the ability to change that JavaScript, then you can take a risk decision to base your trust on that third-party code and continue to serve that. If you have any developers in your organization that are trying to include libraries that are not on your trusted list, then there should be a way to check that. There should be a way to say, no, we are not going to allow this website to include that JavaScript, and we're not going to let that go out the door as and be deployed. That's a software design or a software implementation phase decision, but it needs to be controlled in some ways. It's best, in our opinion, to have that done during the development of a software project and not after it's gone into the wild as it's already been released, because you could already be being attacked and you'd have to change the website that's being used by users. If the third-party organization can't assure the code, so if they are, say, a smaller open source project, if they are say an organization that just it doesn't have the ability to be contacted or to have any assurance of their code, then you can, if you're allowed to legally and if you have the resources, you can bring that JavaScript in-house. So essentially what you're doing as a design and implementation decision during your software development is you're identifying the need for this library, for the functionality that this library provides. And the problem is that you can't trust the way that library is provided because it is done outside your organization. So if it's open source and if you have the ability to do it, you can bring that JavaScript in-house. You can link to it from your own websites in a way that shows this is coming back to our own website. This is coming back to the business, the banking application, the airline application. And you can then just white label in your own checks the ability to say, right, well, we will trust ourselves, obviously, to supply this JavaScript library. We have source control over it now. We know if any changes are going to be applied. We can test those changes. We can ensure those changes are not going to happen without our knowledge. And this allows you to identify ways to protect that code, because if you are auditing yourself, if you're hosting it yourself, that allows it a lot more secure. And it also means if an attacker did want to somehow try and change that third-party code for your website, then they have to go through all the previous attack vectors of getting inside your network, of changing code that you have already tested, of getting access to that code, and that's a lot harder mechanism, a lot harder proposition than attacking a small third-party open source library. So that is our advisory on FormJacking and how it has become so prevalent in today's attacking infrastructure in society, how it's manifests itself and how it can be protected against. One of the reasons why Uleska is covering this as a webinar is because an element of our product allows us to help with that assurance that we mentioned before. Many of the off-the-shelf products, and even open source testing tools do not check for FormJacking. Is not something that is in their remit, and even if they did, they would have to have the ability to input a list of whitelisted domains from which you, as a business, are happy to serve JavaScript from, assuming we take the precautions we mentioned there towards the end. So what we have developed inside the Uleska platform is the ability to plug in what we call custom tools, which means you can take something you've developed, a small testing script or a small Java program, and you can wrap it inside the automation and orchestration provided by the Uleska platform, and that allows you to implement these small types of checks across your whole organization and all applications. So we've developed a small custom tool which explicitly and only checks for FormJacking. You pass in the parameters of the whitelisted domains from which you trust JavaScript to be served from, and upon every deployment or every software security test during like a DevSecOps or a CI/CD test environment, those checks are applied, and if any JavaScript's being included from a domain outside of those whitelisted ones, that is flagged up with a very high risk. At that point, obviously the organization can make their own go, no-go decision, but at least it gives you visibility and a risk prioritization on those FormJacking risks, so you can know if any development team is trying to bring in JavaScript includes without your knowledge and without the coverage or the whitelist coverage of your previous analysis, and you can also be aware and be able to prevent any releases that do need to be stopped because of those third-party includes. If you have any questions or want to know any more about FormJacking or the Uleska platform, please reach out to us at www.uleska.com or reach out to us at info@uleska.com, and we'll be happy to set up a chat, happy to show you a demo of the Uleska platform, and happy to reach out and have a conversation. Thank you very much.